Question 17 says, given that x equals 8 times 10 to the power of negative 3 and y equals 5 times 10 to the power of negative 7, find x squared minus 8y over x times y in the form of a times 10 to the power of n, where a is between 1 and 10 and n is an integer. So another way of saying that is scientific notation. Okay, so let's write out what we're trying to find. We want to find x squared minus 8y over xy. So let's plug in what x and y are. On the top we have 8 times 10 to the power of negative 3, that's squared, minus 8 times 5 times 10 to the power of negative 7 over 8 times 10 to the power of negative 3 times 5 times 10 to the power of negative 7 on the bottom. Okay, so let's start with the top here. We have two numbers multiplied by each other to the power of 2. So we can put this exponent into each of these numbers separately because they're being multiplied. So 8 to the power of 2, 8 to the power of 2 times 10 to the power of negative 3 to the power of 2. Here we can multiply this 8 in. This is all one big multiplication. So 8 times 5 is 40 times 10 to the power of negative 7. And on the bottom, again, this is just all multiplication. Sorry, I should put an x here to make it consistent. All multiplication, so we can multiply in any order we want. So let's multiply the 8 times 5. So we have 40 on the bottom, and that's times 10 to the power of negative 3 times 10 to the power of negative 7. Okay, so 8 to the power of 2 is 64 times 10 to the power of, let's see, since we have 10 to the power of negative 3 to the power of 2, we multiply those exponents, so that's 10 to the power of negative 6, and that's minus 40 times 10 to the power of negative 7. And on the bottom here, we have a 40, and we have 10 to the power of negative 3 times 10 to the power of negative 7. That's the same base, and since we're multiplying, we add the exponents. So this simplifies to 10 to the power of negative 3 plus negative 7, which is negative 10. Okay, so on the top here, what we want to do is subtract these terms. And so one way we can do that is by making this, what we're multiplying by, 10 to the power of something, the same. And then we can combine these like terms. So let's do that. Let's change the second term here. So I'm going to leave 64 times 10 to the power of negative 6. This one I'm going to change to 4.0. So what is the power on 10 here? 10 to the power of negative 7 is telling us we essentially need to move the decimal over to the left 7 spaces. So since we've moved it 1 space to the left already, this changes to 10 to the power of negative 6, because now we only have to move it 6 spaces. So now we have the same exponent here on the 10 in both terms. And so what that means is that we can subtract these terms like normal. We can say 64 minus 4, that answer, times 10 to the power of negative 6. And another way of thinking about that, so that it works, is that we can basically now factor out a 10 to the power of negative 6. And what we're left with is 64 minus 4 times 10 to the power of negative 6. Okay, so 64 minus 4 is just 60. And we're left with that times 10 to the power of negative 6. And on the bottom we have 40 times 10 to the power of negative 10. Okay, so what we can do now is, again, we just have a multiplication on the top and a multiplication on the bottom, so we can divide these in whatever order we want. So I'm going to do 60 divided by 40, and that's 1.5. And with these terms, we have the same base here, and we're dividing. So that means that we subtract the exponent. So this is going to be 10 to the power of -6 minus -10. And so that equals 0.5 times 10 to the power of, it's going to be a plus a positive 10, so 10 to the power of 4. Okay, and is this in the form that the question asks for? We do have a number that's greater than or equal to 1 and less than 10, and our n here is an integer, so great, we have our answer in the form the question asked for. So 1.5 times 10 to the power of 4 is the answer to question 17.